Unpopular opinion. Kubernetes workloads should be optimized only for cost, not performance. Well, that's totally wrong, but you know what else is wrong? Thinking you can't optimize cost while keeping performance front and center. And we get why many teams still hesitate to adopt pod right-sizing automation. The risks feel too high. No one would gamble their application stability just to save a little money for a few hours. That's exactly why at Zesty, we built our pod right-sizing differently. Our approach starts with performance first. We made vertical scaling safer, more predictable, and reliable. With HPA awareness, advanced algorithms, safety mechanisms, and controllable automation. So let me walk you through how Zesty's pod right-sizing works and what makes it different from other approaches to Kubernetes scaling. First, Zesty's pod right-sizing works seamlessly with horizontal pod autoscaler. It's what we call HPA aware, meaning it knows how to scale vertically without conflicting with the horizontal scaling of HPA. And it takes HPA target utilization into account, which means scaling decisions stay consistent with the policies you've already set. Real Kubernetes environments are never simple. They involve many parameters, things like target utilization thresholds, min replicas, workload spikes, and more. Zesty's pod right-sizing is built with advanced algorithms that are designed to handle this complexity. So it doesn't just rely on CPU and memory to make scaling decisions. It analyzes multiple parameters and optimizes at the container level. This way, it ensures that the decision-making is accurate and doesn't impact important performance metrics, even in dynamic workloads. One of the biggest concerns we see with automated right-sizing is that it does what it's designed to do, reduce cost at the expense of performance. Most people would rather spend money on a machine than risk their application stability by reducing that machine's capacity. That's why Zesty's pod right-sizing is built performance first. That means two things: what we account for in every decision and how we execute changes safely. So what parameters do we account for? Zesty collects a wide range of signals from across your Kubernetes cluster, from pod behavior to workload patterns, and uses them to build a detailed application profile. That profile guides right-sizing decisions at the pod and container level, so resources are allocated precisely without destabilizing workloads. By learning from historical usage and recurring patterns, Zesty can anticipate demand instead of reacting blindly, which means scaling decisions are both proactive and performance first. Which safeguards keep performance first? Auto-healing. If a pod fails after a right-sizing adjustment, for example an OOM kill or a crash loop, if Zesty detects OOM events or continuous CPU throttling, it instantly rolls back CPU and memory requests to the latest stable configuration, keeping workloads running without manual intervention. Precision. Once a pod has been resized, the system waits for 2 minutes before moving on to the next one. So instead of applying changes cluster-wide at once, new sizes are rolled out incrementally to subsets of pods. That way, if any instability starts brewing, it's detected early and rolled back before it impacts the entire cluster. Flexible policies. You can choose between the default and conservative optimization options, giving you control over how aggressive right-sizing should be. Controllable customized automation. Automation doesn't mean giving up control. With Zesty, you decide exactly how much to automate. Each workload can have its own policies, so you can tailor auto-scaling behavior to fit different applications, business needs, or environments. In-place pod right-sizing. Finally, Zesty supports in-place pod right-sizing. That means resource adjustments happen inside existing pods without the need to kill and restart them. It makes scaling smoother and non-disruptive. To sum up, Zesty's pod right-sizing works in harmony with HPA. It uses advanced algorithms for complex environments. It's performance first, it gives you full control over automation, and it supports in-place pod right-sizing. All of this ensures that your workloads are always optimized for performance, not just cost. So the next time someone tells you that you need to choose between cost optimization and performance, tell them they know where they can shove it.